In the realm of 3D modeling, we start with virtual skeletons, bare-bones structures yearning for the flesh and blood of reality. This is where textures and materials step in, transforming the mundane into the mesmerizing. They are the digital artist's paintbrushes, the sculptor's chisels, breathing life and believability into our creations. Imagine a solitary sphere hanging in digital space. Is it a polished marble, a weathered baseball, or perhaps a juicy orange? The answer, my friends, lies in the magic of textures and materials. Textures, in their simplest form, are two-dimensional images applied to the surface of 3D objects. They provide the visual details, the colors, patterns, and intricacies that trick the eye into perceiving depth and complexity. Materials, on the other hand, dictate how light interacts with these surfaces. They define properties like reflectivity, roughness, and transparency, essentially dictating how an object looks under different lighting conditions. Without textures and materials, our 3D models would remain lifeless, trapped in a monotonous world devoid of visual richness. But with the right combination, we can transform the ordinary into the extraordinary, crafting digital experiences that are both captivating and believable. So join me, fellow artists and enthusiasts, as we embark on a journey into the captivating world of 3D texturing and materials. Together we'll unravel the secrets behind crafting visually stunning and believable digital masterpieces. Imagine wrapping a present, but instead of a simple box, you're dealing with a complex, multifaceted 3D model. This is the challenge of texture mapping, the art of applying a two-dimensional texture onto a three-dimensional object. It's like meticulously fitting a piece of fabric onto a sculpture, ensuring every crease and contour aligns perfectly. To achieve this, we rely on a technique called UV unwrapping. Think of it as meticulously peeling off the skin of your 3D model and laying it flat, like a mapmaker charting unknown territory. This flattened skin is your UV map, a two-dimensional representation of your 3D object's surface. Each point on your 3D model corresponds to a specific point on the UV map. When you apply a texture, you're essentially telling the software, hey, take this part of the image and put it on this part of the model. Seamless UV unwrapping is crucial for avoiding unsightly distortions or seams in the final render. This process, while seemingly technical, is the bridge between your two-dimensional textures and your three-dimensional creations. Mastering UV unwrapping gives you the power to precisely control how textures are applied, ensuring your models are as visually appealing as they are technically sound. Just as a painter chooses from a palette of colors, 3D artists have a diverse array of textures at their disposal, each serving a unique purpose in enhancing realism. Albedo, or diffuse textures, are the workhorses of texturing, defining the base color and surface detail of your model. Think of them as the foundation upon which all other textures are layered. A brick wall's albedo texture, for example, would show the color and pattern of the bricks themselves. Normal maps, on the other hand, create the illusion of depth and detail without adding extra geometry. They work by tricking the light, making a flat surface appear bumpy and intricate. A cobblestone path rendered with a normal map, for instance, would appear realistically uneven despite being a flat plane. Specular maps control how shiny or reflective a surface appears. A high value in a specular map represents a highly reflective area, while a low value indicates a duller surface. Imagine the difference between a polished car hood and a piece of rough wood. Displacement maps, unlike normal maps, actually modify the geometry of your model at render time. This allows for incredibly detailed surfaces, like the intricate carvings on a statue, without the need for excessive modeling. These are just a few examples from the vast world of textures. By understanding the strengths and limitations of each type, you can combine them to create incredibly realistic and visually compelling 3D models. While textures provide the visual details, materials dictate how light interacts with those details, ultimately determining how an object looks under various lighting conditions. Think of it like this: textures are the skin and materials are the properties of that skin. Color is the most basic property, defining the overall hue of the material. It's important to note that color can be influenced by textures, allowing for variations and patterns. Reflectivity determines how much light bounces off the surface. A highly reflective material like polished metal will have strong highlights, while a matte surface will scatter light more evenly. Transparency controls how much light passes through the material. Clear glass would have high transparency, while a wooden door would have almost none. Roughness dictates the smoothness of the surface at a microscopic level. A rough surface will scatter light in multiple directions, resulting in a softer appearance, while a smooth surface will reflect light more uniformly, creating sharper highlights. This is where shaders come into play. Shaders are essentially mini-programs that tell the computer how to calculate the interaction of light with a material. They take into account all the material properties we just discussed, along with the lighting information in the scene, to determine the final appearance of an object.